Okay, looking at 2B practice. So here there's a couple little differences, but not a whole lot. You first isolate the absolute value. It's isolated in number 7. So then we're going to split it up into 2 problems like we did before. Well, first, I guess I should stop. It's a positive 9 on the opposite of the inequality. It's if it was negative, we would stop and it'd be a special case. It's not. So we're going to break it up. Write one down, one inequality, exactly how you see it with the greater than. The other inequality. So very similar to the last for 2A. You have to think you have 9 is 9 away from 0 and negative 9 is also 9 away from 0. Well, think about it like this. We're dealing with inequalities anytime you multiply or divide by negative 1. So think of it as like negative 1 times 9. Well, then we got to switch to inequality. Inequality always switches on our second problem. So subtract each. X is less than 6. And subtract 3. X is less than, that's a negative 9 minus 3 is a negative 12. Let's do a quick little number line to see if this is an and or an or problem. Negative 12 is on the left side. 6 is on the right side of a number line. Less than negative 12, so open circle, it's like a hole. There's no actual point at negative 12. That's not part of our solution. And 6 is the same thing. It's not equal to and greater than. So this is, they're shading away from each other. This is an or problem. So all you have to do is just write or in between them. Number 8. So we have to isolate the absolute value first. To isolate it, we have to subtract 4. At this point, when the absolute value is isolated, we can evaluate, we can check it out to see, is the right side, the opposite side of the absolute value, is it positive? Yep. If it was negative, we'd stop and it'd be a special case, either no solution or infinite solutions. But it's not, it's a positive 18, so we'll keep going. We're going to split this up into 2 problems. We have 18 is the absolute value could be, or you switch to inequality because you're multiplying the right side by negative 1 to get negative 18. Think of it that way. That's a rule that we learned in Algebra 1 or middle school. Anytime you multiply or divide by a negative number with inequalities, you switch to inequality. All right, so next, add 2. I'm solving both of them. I keep saying just. I am solving both inequalities. So y is less than, I'm going to reduce that down to 10/3 over on the right side. Y we divided by a positive 6, so I am not going to change the inequality. Reduce that down to negative 8/3. On the number line, you don't really have to think about, we know negative 8/3 is left on the number line from 10/3. 10/3 is positive, negative 8/3 is negative. Graphing these, greater than negative 8/3. So greater than, so it's not a filled in circle, and greater than to the right. Those are bigger numbers. 10/3 and less than symbol means to the smaller numbers to the left. They're shading towards each other. Anytime it shades towards each other, we are going to write these as a compound inequality. This is an and statement. So you write them together, and it's really, if you just look at the number line down below, it's how it's going to be written. You just write less thans. So it's saying the number has to be between negative 8/3 and 10/3. And that is actually, this is a compound inequality it's written. Number 9. We have, all right, now is this first time we have the absolute value. It's not isolated, and there's more than one operation on the outside. So we really got to think about order of operations. We have a plus here and a multiplication. Order of operations, we would do the multiplication first, then add. So we have to do the reverse order of that. So subtract first. So 1/4 times x minus 3, absolute value of it, is less than negative 1. So you can multiply by the reciprocal here, 4/1, or just 4. And you get 1 times the absolute value is the absolute value of x minus 3. We did not multiply by a negative number, we multiplied by a positive 4, so the inequality stays the same. The absolute value now is isolated, no operations on the outside of it. And we look on the right side very carefully. Once it's isolated, we look on the opposite side of the absolute value, it's a negative number. So this tells us this is a special case. So that when that happens, when the absolute value is less than a negative number, this means that we're going to have no solution. I'll explain that a little bit more. So that's our answer. The absolute value, think about what absolute value means. It's distance from zero. Distance is always a positive number. Can a positive number be less than a negative 4? No, it can't be. All positive numbers are greater than negative 4, but that's not what this statement says. So it has to be a no solution. All right, number 10, working this problem out. I would actually tell you guys, let's work this problem out separately, and then we'll compare it to the work on the paper we see. So it's much, much easier, I've found over the years, to do it this way than to try to see where an error is. Really hard to see someone else's work and be like, oh yeah, that's where the error is. But when we work out the problem on our own, we can then compare it and we can just look. Much easier. So we isolate the absolute value, so we add 6. The absolute value is isolated, and the right side is a positive 13, so we can move on. We have 2x plus 3 is greater than or equal to 13, and we have 2x plus 3 switched inequality, and it'll become a negative 13. Solve each problem. I have not looked at the actual problem to this, so I don't know if we've already come up with the error or not, but I'm going to keep, what did I just do? I'm going to keep solving. I divided by a positive number so I don't switch to inequality. I'm going to keep solving until I'm done. Then I'm going to compare. Much easier to compare what we see in front of us. That's a negative 8. All right, so we have x is greater than negative 5. Compare those, good. But I see right here the 2 is not right. So where is that? Where did that go wrong? Oh, it's all the way up here at the beginning. The 7. The 7 should be a negative 13. So they did not add 6. They went right back to the original. They put 7 here instead of a negative 13. So that's the error. Cool. I'm glad we found that. So number 11, I'm going to do the exact same thing. I am going to write it down. Don't pay attention to all this work down here. Don't pay attention to that. We'll get to it later. We need to isolate the absolute value. We divided by a negative number, so we're going to switch the inequality to greater than a negative 11. Absolute value is isolated, and what does it equal? Equals a negative number. This is a special case. So we're looking at the inequality. The inequality is greater than. Think about it. Absolute value is a positive number, and can a positive number be greater than a negative number? Oh, shoot, yeah, it always is. So it always is means it's infinite solutions. Meaning every number works. So that's it. So at this point, this was the problem, and that should tell us it's infinite solutions. So when we compare it. All right, last problem. Number 12. So we have minus 2 on the outside. Absolute value, the x minus 3 divided by 2 is all underneath the absolute value. The absolute value is isolated. On the right side of the opposite side of it is a positive number, so we keep working this out. Divided by 2 is less than 4. The other the other solution is going to come out of switch to inequality, switch the sign, times 2 times 2. add 3, x is less than 11, times 2 times 2, and multiply by a positive number, so we do not switch to inequality. Greater than 11. Interesting. Oh, no, I made a mistake. My bad. Made a mistake. Doing this too fast. -8 plus 3 is -5. Alright, let's do a number line to see if there's an and or an or problem. -5 is less than 11 on a number line. So on a number line, it would appear to the left. Open circle, because it's not equal to, it's greater than, so it's to the right. 11, open circles, because it's not equal to, and it's less than, so it's towards each other. So this is an and statement. So how we're going to write it, it's -5 is a smaller number. They're not equal to, so it's less than x less than 11. That's a compound inequality.